Hello everyone, my name is Meet Sangvi and today we are going to be looking at a Schmitt Trigger circuit using IC OP07. So over here we can see this is a Schmitt Trigger circuit. So what a Schmitt Trigger basically does is it performs the same function of a comparator but with an added bonus of better noise immunity. So this is because instead of providing a separate voltage as reference, we are just seeding back the output through this voltage divider as the reference voltage. So in a comparator, even with slight changes in the input and due to noise, the output used to come out as an unwanted output, but in this case that won't happen. So now we will run the circuit. So yeah, this the sine wave will be 0 as offset, 8 amplitude and 500 frequency, and the resistors will be 1.5k and 1k. Now we will run the circuit. Click over here at Vn. So as you can see, the input is sinusoidal and over here output is square wave, just like we got in the comparator circuit. So yes, now we will see the stable multivibrator. We shall see a few modifications of this circuit, like a stable multivibrator, triangular circuit, triangular wave generator and sawtooth wave generator. So this is the stable multivibrator over here. It basically uses the same concept as the Schmitt trigger, but one of the features of this is you don't actually need an input voltage. You don't need to provide an input voltage, and it can just amplify the noise it receives at the input terminal. So we first place a capacitor at the input and we also provide a feedback resistance R3 over here. Now we will run the circuit. This is the Vin. Click over here. So as we can see, the input is like charging and discharging of a capacitor, and the output is the same as the Schmitt trigger, a square wave. So this means that the Schmitt trigger is capable enough to amplify its own noise and give us an output. Yes, now we will move towards triangular wave generator. So what we have done over here is we've taken an unstable multivibrator till this point, and then we've added two Zener diodes in anti-parallel to basically clamp the voltage down to 5 volts. And after that we have added a simple integrator circuit over here. So now what integrator circuit will do is it will take the input as the square wave from here after diode, and it will integrate it and give us the output as a triangular wave. So we will run this circuit. I'll just close this, run again. This is the Vn. Click over here. So like as we can see, the input is like charging and discharging of a capacitor. Now we shall click in the middle of the diode and the resistor over here. So this is the kind of wave we get, like we used to get in Schmitt trigger. And now we click over here. So we can see that the voltage over here has been clamped to 5 volts because of the two diodes, and this is the output which is in red, and the green shows the capacitors charging and discharging. Then the diodes, we get a square wave which is the same as a Schmitt trigger or an unstable multivibrator, and the final output is the output of the integrator, which is a triangular wave we can see in red. So now we will go to sawtooth wave generator. So this is the sawtooth wave generator over here. This again works on the same principle as the Schmitt trigger. Over here we don't even need to provide a capacitor at the input. We just take this and run. I run the circuit, close this, run again. We just need the output, so I'll click over here. So we can see the output is directly a sawtooth wave. So this circuit uses the same principle as Schmitt trigger and gives us a sawtooth wave as the output. Yeah, that's it. Thank you everybody. Thank you very much.